Welcome to Study Loop.
So here in this question, air flowing through a nozzle experiences a normal shock. That is the air. Okay. Now the effect of a shock wave on various properties are to be determined. And also this has to be done for helium also. And there should be a comparison here. Now here also we have to consider certain assumptions. And the first assumption is that air and helium are ideal gases. This is the first assumption. The second assumption is the flow through the nozzle is steady, is one-dimensional, and isentropic. Right? Now, the properties that we consider here is specific heat ratio of air 1.4. For R, it is 0.287 units. And the same, this is for air. When you consider for helium, this is K equals to 1.667, and we have R equals to 2.0769 kilojoule per kg Kelvin. So these are the things that we have. Now as we move forward, the properties of the upstream shock, the air properties of upstream shock. Okay, upstream shock, the air one. So here we see that MA1 equals to 2.6, P1 equals to 58 kilopascal, T1 equals to 270 Kelvin. Now fluid properties after the shock is denoted by subscript 2, are related to those before shock through the functions in table A33. Now for MA 2.6, the aftershock match number would be MA2, and that is equals to 0.5039. We are getting it from the table, okay? Now PO2 upon P1 equals to 9.1813. P2 upon P1 equals to 7.7200, and T2 upon T1 equals to 2.283. Got it? Now, so we obtain these values using analytical relations in table 14. Now the stagnation pressure PO2, static pressure P2, and static pressure T2 is determined by this formula. From this, the above formula we get PO2 equals to 532.5 kilopascal. The static one is 447.8 kilopascal, and the T2 static temperature is 640, um, it's 604.3 Kelvin. Okay. Now, then we see that the air velocity after shock can be determined by the equation V2 equals to Ma2C2, that is Ma2 root of KRT2. So keeping all these values, we get V2 to be 248.3 meter per second. Now, this we have considered for air. Till here, whatever we did was for air. So similar things when we see for helium. Okay. Now the second case is of helium. We get Ma2 to be 0.5455, P2 is equals to 475.7 kilo. Same formula. Okay, P02 is equals to 602.5 kilopascal. T2, it is 799.4 Kelvin that we have. Now, V2 equals to 907.5 meter per second. So when you see the velocity and the Mach numbers are higher in case of helium as compared to the air. So understood this question?